Okay, boys and girls, we continue the last week lesson 42B. We still have page 15 and 16. We completed it. Okay. Uh, Question number 10. This is 2023 past year questions. A student set up a circuit with a battery, emitter, heater, LDR all in series. Okay, all in series. The battery has negligible internal resistor. When we study about this chapter, we keep on solving the question saying that negligible internal resistance because today we will enter new chapter 10. Okay, we will learn about what is internal resistance. Okay, but in chapter 9 we haven't touched it, so all the questions that I selected out, they will mention that, hey, now the battery has negligible internal resistance, so we ignore this. Okay, and what is internal resistance today we'll learn. Okay, voltmeter will be connected across in parallel with the heater. So complete the circuit diagram. Okay, lesson number 43, we were having a list of symbol. Okay, but without the list yet, we also able to answer this question is because in our year 10, year 11 and form 5, we learn all the symbol. We learn the symbol about the ammeter, voltmeter, heater, and LDR. We already know about this. Okay, so we should able to answer this question. Okay, so we look at here. Ammeter symbol is like this. Okay, then heater is like this. Then at the center got three line. Okay, LDR, I told you already, LDR is a resistor. So the basic structure actually is a resistor structure. Then LDR is light dependent resistor, is we receive the light. Receive the light. So the arrow should be pointing in. Okay, from the left or from the right doesn't matter, but the arrow is pointing in. So we need to make them in series. So we can do like this. Okay, ammeter. Okay, then heater. Then LDR. Okay, LDR pointing in. So this is LDR. This is heater. This is the ammeter. Okay, then what else? A voltmeter is connected across the heater. Across the heater. So where should we put our voltmeter? We should put at the heater there and parallel with the heater. So we should draw like this. Voltmeter. Okay, this is voltmeter. So for this question is 3 mark. If you get a correct symbol for heater and LDR, so you get 1 mark. Then all the symbol is connected in series. Ignore the voltmeter ignore the voltmeter first. Others, if you connected in series, then you get the second mark. Then voltmeter connected parallel with the heater, that is third mark. Okay. So at here, total 3 mark. So it's easy. Okay, for this part, 10 seconds. You draw it, and then you can try with question B. The heater is a wire made of metal resistivity 1.1 times 10 power of negative 6 ohm meter. The wire have a length 2.0 meter and cross-sectional area is 3.8 times 10 power of negative 7 meter square. Voltmeter reading is 4.8 volt. Can you calculate the resistance for the heater? Okay, do your calculation right now. You should already familiar with the formula. Resistivity, the length, cross-sectional area. This one is the voltmeter reading. So this one is across the heater. So I will write in this way. Wow, Vashini very fast. Yes, correct. Make sure write the formula, substitution, and final answer. Then Vashini, you can continue. How about others? Resistance involved with resistivity formula. Let me check Fawal. Yes, correct, Fawal. Normally, you need to be careful whether they put any prefix or not. So you have to check. The unit, is it correct? If got prefix, then you have to convert it. Okay, 凯谦 correct. Jore correct. Unit Prasan correct. 5.8. Oh, okay lah. They're giving the unit already. 5.8 ohm. Okay. So what is the reading on the ammeter? So do your calculation and tell me what is your reading for your ammeter. Washini correct, yes. Fawa correct, yes. Okay, so V equals to IR. Okay, what we know about the voltage for the heater. So we can using this information to do calculation. So for the heater 4.8, this is heaters. I write hash lah. Current for heater, resistance for heater. Current for heater, we don't know. Resistance, just now we did calculation 5.8. So your current for the heater, actually, if you do it correctly, you should get 0.83 ampere. Okay, my question is, this 0.83 ampere actually is the current for the heater what? Why it can be represent the ammeter? Kai Chen correct. Manjo correct. Okay. Why? This one is the heater current. That I do calculation, I using all the information is about the heater. So my final current is also heater. But why this heater 0.83 ampere can be represent the reading on the ammeter is because this is a series. Okay, series circuit. So series circuit, when we know about the heater current flowing through the heater, I also can know that 0.83 ampere also flowing through the LDR. So in series circuit, current will be the same. Okay, should be no problem for you guys. Okay, we goes to the C. C part. C. The heater is now replaced by a new wire. The wire is made from the same metal. Okay, same metal, that means that same resistivity, same resistivity as the wire in B. And it has the same length L, but larger diameter. Okay, diameter increase. Resistance of LDR remains constant. So state and explain whether the new wire has a resistance that is greater, less than, or same as that of the wire in B. What do you think? New wire having a resistance greater, less, or actually unchanged, same as the B. Is it same metal, same resistivity, so it will having the same resistance? Is it? Or how? Okay, Wesley, yes. 2 marks. So Wesley, why? Fatima, yes. But why? Yes. But why? Your reason is not correct, Farima, but your answer is correct. Correct. Wesley, correct right now. This is the answer. When diameter increase, Washini answer, when diameter increase, area for the wire will increase. Yes, you don't repeat because the diameter become larger. If you just repeat the sentence, most probability you can't get the mark. You have to mentioning, hey, because the larger diameter, so the cross-sectional area increase. This is a very good answer. Hence, resistance of the new wire become less. Okay, less than the resistance. Yes, Washini answer is perfect. Okay, Prasan say resistance decrease because R is inversely proportional to D square because the resistivity and the length is the same. So, yes, correct. Rho L over A. This one constant, yes. Prasan, I still encourage you mentioning about area because in the resistance formula is mentioning can, actually can. So we can also say that L over pi D square, then here 4. Okay, can, Prasan, okay? Your answer, okay. Okay, so boys and girls, we're trying to mention about larger diameter, then area increase. So area increase, that means that your wire right now become a thicker wire. Thicker wire, actually, it allow more current to flow, so your resistance will become less, okay? So resistance decrease. Okay, why? Because cross sectional area increase due to the larger diameter. Okay. Okay. Or you mentioned like just now, Prasad say R is inversely proportional to D squared. Yes, correct. Okay, state and explain whether the new reading on the voltmeter is greater than, oh, voltmeter, or just now the voltmeter is across the heater. Okay. Now it's greater, less than, or equals to 4.8. Hmm, what do you think? Voltmeter reading is this voltmeter is measured across the what the heater across the heater. So right now your new reading on the voltmeter will be greater, less than, or equal to 4.8, because just now at here they tell you voltmeter reading at here is 4.8 volt. Now I change the heater wire, so right now you have to think. Your new reading on your voltmeter should be greater, less than, or equal to 4.8. Wesley, your new reading on voltmeter is correct, but the reason not correct. Reason is not related with amplitude. Vashini, when resistance decrease, voltage decrease. So the new reading on voltmeter is less than 4.8 volt. Yes, dear, when here you're using a larger diameter, your resistance will decrease. So when your resistance decrease, this one you can explain based on what? Based on the potential divider. They share voltage what? Share voltage. So if this one resistance decrease, it will get less share. So Vashini answer is correct. The voltage across the heater will decrease. Okay? When the resistance of heater decrease, voltage across the heater will also decrease. It will get less share. Okay? So at here, okay, voltmeter reading is less than 4.8 volt. Why? It's because heater resistance decrease, so it has a smaller share of total voltage. Okay, I can draw something like this to show you some calculation. If let's say I got two resistor, one is 6 ohm, another one is 4 ohm, another one is 2 ohm. I got total 6 volt. So the current flowing through the circuit is 1 ampere. Okay, so 1 ampere times 4 ohm, so it will receive 4 volt. Then 2 ohms, it will receive 2 volt. So in total, we get back the total 6 volt lah. Okay, so here I want to tell you, you see, when the resistance is small, it will get less share. It will get less share. But here resistance is high, larger resistance, so it will get more share of voltage. So when we are having a larger diameter, that means that thicker wire. So when thicker wire, then resistance decrease, then it will get less share of voltage. So at here, if I connected with a voltmeter, so this voltmeter reading will decrease. This is the knowledge about potential divider. Okay, it share the voltage. So you write it down. Okay, there is another one more answer they can accept is, okay, go back to the front page. One more answer they can accept is how you explain when your resistance of heater decrease. So that means that your overall resistance is decreased. So your current in the circuit will increase. So current in overall will increase. That means that this voltage, it will receive high current. Actually, heater also high current, but for LDR also high current. So voltage across LDR actually will increase because V equals to IR. It receive higher current. So for this part, it also receive higher potential difference. So at the end, your heater will receive less. This is another way answer they can accept. Okay, but I feel that this one is more complicated a bit lah. Okay, I repeat again. When your heater resistance decrease because thicker wire, so your total current in the circuit will increase. So total current increase, voltage across the LDR actually will increase. Okay, LDR will receive more voltage. So here receive more voltage, then heater will receive less voltage. That's all. But for us, more easier is resistance here decrease. So according to the potential divider, how they share, we understand that if the resistance decrease, voltage share by the heater, it will receive less voltage. That's all. Finish. Okay, is it okay for this part? Okay, Fatima, okay, Vashini, okay. Okay. So all the explanation here, finish writing. Okay, here. Define the ohm. Easy, easy. Last week we did practice for a few times. So if they're asking ohm is the unit, so we have to think resistance is V over I. In terms of unit to explain the ohm. Many of you already answered for a while. Watts per ampere, yes. Watts per ampere, Farsan, yes. Okay, so write down watts per ampere. Don't write voltage per ampere. Sometimes we write too fast, then we think that watt and voltage we mix up. Okay, watt no S. Watt. Okay, here. This question actually we did it in MCQ. Same question in MCQ. Okay, a wire is made of metal of resistivity rho. The length L is gradually increased. We increase the length. Okay. Then assume that the volume still remain the same. As the length increase, volume is area times the length. So when your length increase, here this one volume is constant. That means that your area will change also. Length increase, your area will change. It no longer constant. Okay, show that the resistance is proportional to L squared. So boys and girls, I start with here, rho L over A. They want you compare relationship between R and L. Normally, we can say that R is directly proportional to L is because resistivity and area is constant. But for this case, I cannot say R is directly proportional to L. And the question tell you R is directly proportional to L squared. They ask you to prove. Okay, give you 30 seconds. Can you try before I give you the answer? Actually, in MCQ, we did this question before that. You try? So area and length is changes. So you need to replace area to something constant. You cannot use A in your formula because A will change. Then L will change. It will affecting the R. So cannot have A in your formula anymore. At the same time, trying to find for the this question. This is lesson 41. Page number 4. They're asking you to find the graph that can represent R with L. So at the times, we will have the L that is changes, others variable have to fix, and then related with the R. Okay, so at the end, for this question number 5, our answer is D, is because R is directly proportional to L square. So answer will be D, R is directly proportional to L square. So it's a curved graph like this. Because here is L, not L square. If L square, then it will be straight line. Do you able to find the answer? Proof? Any of you able to find? Able to prove it? Kai Chen okay. Vashini okay. Able to prove. Good job. How about others? Wesley okay. V over L. Okay, so at here, so V over L. So it will become L square over VR. So can you see that volume is constant? Resistivity is constant. So here I prove that R is directly proportional to L square. Okay? Proof like this. So can you see the relationship? Actually, these two questions are the same. Do you able to get this question idea? This idea? Do you able to link this question and just now the question? Power okay, huh? Able to prove. Good job. Okay. Then we goes to our lesson number 43. Okay? So we goes to our lesson number 43. Actually, it's chapter 10, DC circuit. Okay, just now I got mentioned we will practice some electric symbol. Okay, but most of the symbol we already learned in year 11 or from 5. Okay, so here switch. Okay, switch, this is open lah. If closed, then this one will dot, then actually the straight line closing. Okay, then this is cell, more than one cell we call as battery. Longer line is positive, shorter line is negative. DC power supply, that means that current only can flow in one direction, so it's always from positive go out and then go back to negative. AC is this one. Okay, year 10, year 11, we learn about AC generator. AC generator, the current directions will be keep on changing. Okay, that's why it's having the symbol like this. Actually, it's come from the graph that we plot from AC generator. Okay, so from here, then we plotting the graph. We using the graphs as our symbol in AC power supply lah. Okay, then this one is lamp, or we call it as bulb, transformer. Then this one is earth or ground. Oscilloscope, this is something new we didn't learn in our year 11. Okay, so you draw together like this. Something like this. Voilà. Okay. This is oscilloscope. Oscilloscope can display wavefront. Okay, wavefront, waveform. Not wavefront, it's waveform. Okay. So next, here, potential divider. This chapter we will learn about potential divider again. So the symbol for potential divider is like this. Okay. The symbol is like this. It's something like cutting. It make it two resistor. Become two resistor, two part. Okay, divide the voltage. Okay, fixed resistor, this is fixed resistor. Variable resistor, that means that we can change. Okay, we can change the resistance value by adjusting manually. Okay, so the symbol still resistor symbol. Just we need to add it up with this. Okay, then fuse easy. Fuse is a thin wire. There is a thin wire, so we draw a line like this inside a box like this. Okay, actually this one's to represent the thin wire in the fuse. Thin wire. Okay, thermistor is to detect the heat. Okay, detect the heat. So thermistor actually is also a resistor. Also a resistor. So the structure also a resistor. Then like this. Oh. Okay. LDR just now I got mentioned is receive the light. We detect the light intensity. So the arrow should be pointing in. Heater. Heater, just now we did the past year question asking us to draw the heater. So here one line, two line, three line. Okay, heater. Okay, here electric bell and the buzzer. The symbol is quite similar. This is the bell. This is the buzzer. Upside down only. Okay. So how am I going to memorize about and differentiate between these two? For me, for myself, I'm trying to find some technique. So for me, buzzer here, you see, it's a thread, but electric is like up, down, up, down, up, down. Okay. Got like this, going down, then T go up, go down. Buzzer is thread. So buzzer here for me, I remember in this way. You can use others method to memorize as long as you're able to differentiate between these two. Okay, Prasan. How are they connect to the wire? Connect, 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 connect. Prasan, okay? Just connect at here. Da, 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 da. Okay, so you need to think the technique for you to know that which one is buzzer, which one is the bell. For me, here I remember zigzag. Okay, here go straight. So here this one is straight. For me, I using this way to memorize to differentiate between these two. Okay, then here galvanometer, ammeter, voltmeter, generator, motor, diode. Okay, diode. LED is one type of diode. You see, light emitting diode. So actually the structure is same like the diode. So we draw it out like this. Okay, light emitting that means that go out. So now your arrow should be pointing out. It's different with the LDR. LDR is pointing in. We receive the light. Okay, LDR is we receive the light. LED is we emitting the light. So it's going up. Okay, then loudspeaker, actually the structure is okay. This is loudspeaker symbol. The last one, microphone. This is microphone. You go karaoke having the microphone. The symbol is like this, but then we add one more line. Okay. Connected here and here, here and here. How is loudspeaker and power? Power. Okay. Okay, next. So this one is all the symbol that you need to know how to draw. You need to know how to draw. But I didn't include exercise regarding the symbol. Very straightforward lah. As long as you know the symbol, they're very straightforward asking you which one is the symbol for the microphone, which one is the symbol for the electric bill. Okay, so that's all. So comes to here, electromotive force. Okay, EMF. In any complete circuit, we must have the energy provider. Okay, we know that current trying to flow, but they must have some source to pushing the current to flow. So what is the source pushing current to flow? Answer is the EMF in the circuit, or we say potential difference. But for EMF, this one is for the source. Okay, the source. So normally it's for the battery, power supply, whatever power supply, we call it as EMF. Okay, connected what we say, component we cannot say that is EMF. EMF only for the source. So it's the electrical work done by a source. It's a source in moving a unit of charge around a complete circuit. It makes sure it complete the circuit. Sometimes at here we will say energy, okay, but doesn't matter, it's work done or energy is the same, because work done is energy transfer. Okay, so when we buy some battery, here they were writing 3 volt, 1.5 volt, 9 volt. This is called EMF of the battery. Okay, the EMF clearly display on the packaging. In symbol, EMF is given by, here we're using E, but we can also just write EMF lah, doesn't matter. So this one work done, so we can using W divided by a unit of charge Q. A unit of charge Q. Okay, so EMF, although there is a word of force, but this is not a force. This is not a force. EMF unit is in volt. Okay, in volt, work done in joule, charge in coulomb. So EMF is measured in, we are measured in the unit of volt. Or if based on the formula, it will be joule per coulomb. Joule per coulomb. Joule per coulomb. Oh, here we are A level already, so we were using joule per coulomb like this. Okay. Okay, how we measure the EMF of the battery? Sometimes after we use for a long time, then battery will drop. Okay, the voltage will drop, the EMF will drop. So we can measure it by using voltmeter. Voltmeter connected in parallel way. Okay. So if the battery we connected in series, so if series easy, okay, here go up positive from here, this one also positive go up, they are in the same direction, connect in the correct way. So this one we just add it up together, so this one will become 2.4 volt. Year 11 we're also talking about this. Okay, this one is they connected in the wrong way. This one positive go out, here go out, so actually they cancel out. Okay, this one will cancel out, so this one will become 0. Then if like this, okay, if here 1.2 volt, here 1.2 volt, here also 1.2 volt. Okay, what is your EMF, total EMF at here? So this one, my answer is it will become 1.2 volt. Because one of them is cancel out another one. Then I still have 1.2. Okay, I still have 1.2. Then if the cell are connected in parallel way, it's same like we connected in the parallel circuit. The voltage actually will be the same, 1.2. Okay, then here, teacher, since we connect in parallel way, it's still getting 1.2. Why not we just using one cell enough? Why we need to connect it in parallel way? Okay, Prasan say 1.2. Yes, just now this one 1.2. Okay, this one 1.2. Why I still need to connect in parallel way? Why not I just use one battery? Okay, the answer is on page number 3. Okay, we goes to page number 3 at here. Why we need connect the battery in parallel way? Okay, here we look at the single battery first. This one example, in order to let you see clearly, so we put some value here. E1 is 4 volt. So this one is 4.0 volt. E2 also 4 volt. The resistance for the lamp is 2 ohm. So this one is 2 ohm. Here is 2 ohm. This one is 4.0 volt. This one also 4.0 volt. Okay, here, first case at here. 4 volt. EMF is 4 volt. The bulb is 2 ohm. What is your total current in the circuit? V equals to IR. 4 divided by 2. So I know my current flowing in the circuit is 2 ampere. Okay? What is the difference when I connected one more battery in series. Okay, and the direction is correct. They're having the same directions. So at here, your total voltage will become 8 volt. Add it up together. So 8 volt. So what is your total current right now in the circuit? Your total current will be 8 divided by 2. So it's actually 4 ampere. So can you see that when you connected one more battery in series, actually it will increase your current in the circuit. If you want higher current in the circuit, then you connect one more battery. This is one of the way. You increase the V equals to II, you increase the voltage. Of course, you can increase the current because resistance for the bulb is the fixed answer already 2 ohm. Okay, now how about parallel? How about parallel? Okay, can you try and then tell me? Look at this third case, parallel case. What is your total current here? What is the total current flowing in this circuit? Why I need to connect my battery in parallel way? Since it's also giving me 4 volt, why I need to connect it in parallel way? What is the total current in the circuit in third case? I can say 2 ampere, yes. Then what is the difference between the first one and the third one? Why I need to connect in parallel way? Any of you got the idea? Power 2 ampere, yes. Now my next question. Why? Why not just one battery? Why I need to having two battery connected in parallel way? Since here 2 ampere, here also 2 ampere, 2 ohm, 2 ohm, provided 2 ampere to the 2 ohm. But why I need to connect the battery in parallel way? Any of you know the idea? Because E1, E2 has the half current. Yes, Fawa, correct. Like boys and girls, look at here. This is 2 ampere. So at here, current from the E1, I only need 1 ampere. E2, I only need 1 ampere. Can you see that just now for the first case, the battery have to provide 2 ampere. One battery have to provide 2 ampere. But right now, E1 and E2, they connected in parallel way. Actually, they just need to provide half the current, only 1 ampere. So when we connected the battery in the parallel way, actually we can allow longer life, can use longer, okay, can use longer, and then give less power output from the battery. Why? Because current decrease, less current needed to provide it. So the power output power can be give the less output power. Okay, so until here, is that clear? Connected in parallel way, your battery will not be drained out faster. So you no need to keep on changing your battery. Okay. So we try with the past year question. Okay, another battery Q. Okay, here initially is only one battery. Now I got another battery Q. Negligible internal resistance is now connected to the circuit 5.1. So I produce a new circuit with connecting the another battery Q parallel way to the battery P. State whether the additions of battery Q will cause the current to decrease, increase, or remain the same in X. Okay, in X at here, resistor X, current will increase, decrease, or remain the same. Then how about battery P? So can you try to think? Actually, the theory we learned just now, through the example, we already learned the theory. So right now, apply the theory comes to here. Any of you? Wesley, correct. Yes, both answer correct. Jore, yes. Jore, yes. Wow, one correct, one not correct. Washini correct. Okay, you can relate to the example just now at here. Okay, I connect one battery parallel with it. My bulb at here, current increase, decrease, or unchanged? Ask yourself. Fatima, correct. So can you see that 2 ampere here, also 2 ampere across the bulb? So at here, the current across the X and current at here X, it doesn't change. Resistor X will receive the same current. So this one should be remain the same. If here, this is the current I, so here still current I. Why? Because total EMF is still 1.2. Total EMF still 1.2. Okay, total resistance is still X and Y, doesn't change. V equals to IR. So your EMF doesn't change, your total resistance doesn't change, your total current also didn't change, remains the same. Okay, then how about the battery P? Battery P at here. Okay, what is the current provided by battery P? Because here, two battery connected in parallel way. So I understand that I over 2, half of the current enough already to provide total current I. So at here, this one, it should be decreased. Okay, current in the battery P should be decreased. So this question actually same as this example. So battery at here only need to provide 1 ampere current. So current already decreased from just now 2 ampere, now only need 1 ampere. But for the total current in the circuit, it still remain unchanged. Because total EMF is still 4 volt, total resistance still 2 ohm. So your total current still 2 ampere. Okay, is that clear? Is that clear, dear? Fatima, okay. Vashini, okay. Okay. So next, difference between the EMF and potential difference. Okay. So this one, year 11, we learn. Okay. Source. At the source part, we say that this is EMF. We call it as EMF. Across the component part, we call it as potential difference. Okay. Can be work done, can be energy, doesn't matter. It's the same. So for the EMF at here is complete the circuit. Okay, so for the potential difference is passing through the component, or we say from one point to another point. Okay, then what else? Okay, so next, using energy transformation. So how energy transfer lah, okay? Describe the EMF of a battery and the potential difference across a resistor. So you need to think, EMF of a battery from what energy to what energy? Energy transfer from what to what? Any of you know? EMF of a battery. So from what? Batteries, what energy? To what energy? To complete the whole circuit. So what energy to what energy? Year 10 we learn. Battery is what energy? From what energy to what energy? Prasan correct, yes. Fawal, chemical to what? Wesley, chemical to what? From chemical, yes. From chemical to EMF of a battery. So we start from battery is chemical. To what? Washini, electrical, yes. Electrical, okay, per unit charge. Okay, energy from chemical to electrical. So why chemical? Battery. Then why electrical? It let current to flow. Electrical, okay? So how about potential difference? Across component, okay? So what do you think? From what to what? Okay? So most of the time, energy. So this one is repeat energy transfer from electrical, because current flowing through the resistor, okay, resistor. So electrical to what energy? Thermal. Resistor will get hot. Thermal energy per unit charge. It depends on what component, okay? It depends on what component. So for resistor is the thermal. If across the lamp or bulb, and then electrical to light, okay? Is it okay? Okay, then here, a cell has an electromotive force 8.0 volt and negligible internal resistance. The cell form part of the circuit as shown. The reading V1 is 4.0 volt. The reading of V2 also 4.0 volt. What is the resistor R? So think, what is your resistor R? Actually, no need calculation. You should able to give me answer. V1 and V2, the voltmeter showing the same reading. Then, what must be the same? Then can you deduce what is your resistor R? Fawal, correct. How about others? Fawal already get the idea. Washini, correct. Fawal, are you doing some calculation or you can straightly from the diagram to know the answer? Are you doing some calculation? Any others? Read from diagram. Good. Okay, dear. 4.0 volt. Here also 4.0 volt. Meanings what? Meanings both of them must have the same resistance. Fatima answer correct. Must have the same resistance value. So this one connected in parallel way. So that means that it resistance actually for this part should be 4 over 2 is 2 ohm watt. Okay? It's 2 ohm watt. So that means that your R at here also 2 ohm. Answer should be B. Okay? If you still don't know, then I roughly like draw something like this, something like this, something like this. Okay, let's say here 8 volt. Here tell you forward and here forward. Then here is 2 ohm. Then of course we must know that this one also 2 ohm. That is the idea. Okay, 8 volt. Then the V1 and V2 having same voltage, that means that they're having same resistance. So you have to solve this part. What is this resistance value? So it's 2 ohm. Then your resistance for measuring for your V1 also 2 ohm. That's all. Okay, So no question, we goes to your page number 5. Page number 5, if you are not studying government, Malaysia government school from SPM, graded from SPM, then you don't know about this. This is a new thing for you. If you are study IGCSE, this is a new thing for you. But you are SPM student, graded from SPM, actually this is not something new, okay? But we practice with the past year question. Okay, here, internal resistance. So in previous chapter, we keep on having read the questions, then they were mentioning negligible internal resistance. Now is the time for us to learn what is internal resistance. Okay, in the open circuit, that means that the circuit at here we open, we didn't close the circuit, we didn't let the current flowing through the circuit. Okay, it's open circuit. We put the voltmeter across the dry cell. We found out that, let's say, okay, two battery is 3.0 volt. So this voltmeter actually is measure the EMF. It's measure EMF, okay? But after that, when we close the switch, we found out that, why just now my voltmeter showing 3.0 volt? Right now it's only 2.80 volt. What's going on when the switch is closed? Then I lost 0.2 volt right now. What's going on? It's because right now, inside my battery here, we having an internal resistance. We having something hidden, okay, here. Inside the battery, actually, we have a part called internal resistance right now. Okay, when current flowing through the circuit, this one appears, okay, because some chemical, okay, electrolyte. So at here, the voltmeter that you measure right now is not EMF anymore. It's not EMF. The 2.80 volt actually is measure the potential difference across the component outside the circuit. Not outside the circuit lah. Not inside the battery here. Okay, here. So the 2.80 right now actually is measuring this part, measuring the component. Okay, now I show you the video. Mm, okay. Okay, this one. I start at here. I use two battery. It will showing you 3 volt, roughly 3 volt lah, okay? Then circuit is open. The bulb doesn't light up. Circuit is open. So now I close the circuit. Bulb lights up. Okay, I read again. Now only left 2.2 volt. Just now it's 3, now it's 2.2. Where is the 0.8 volt going? Actually, it's because internal resistance. Some energy dissipated due to the internal resistance. Okay, so here. Okay, based on the diagram above, the value of potential difference across the bulb, 2.8 volt, is smaller than the EMF 3.08 volt. Previously, when we learn, without learning about internal resistor, we will say that if here 3 volt, here should be 3 volt what? This is a perfect case. Okay, now we learn in our real life. This impossible it will receive all the 3 volt. They have some losing in the battery due to the internal resistance. Okay, all the question that we did previously, we will just assume that all the voltage from the EMF battery here will give to the what component. But now no, okay, no, we found out that no, now only 2.8 volt. Where is the 0.2 volt? Okay, so here indicate there is a voltage drop. Voltage drop 3 minus 2.8, so we drop 0.2 volt. Okay, so what caused the voltage drop is because inside the internal resistance. Okay, there is internal resistance. So this internal resistance, we use a symbol small r. Okay, components resistance, we say capital letter R. Okay, here. So for this part, actually, this is the battery. This is the battery. Inside battery, we got internal resistance. Okay. So let's say here 3.0 volt. Just now we measure at here. Open circuit is 3.0 volt. Then after that, we measure and close the switch. I found out my voltmeter is 2.8 volt. This 2.8 actually is across the component. So I write at here 2.8 volt. So where is the 0.2? Actually, is here, 0.2 volt. Okay? So from here, we can derive the formula E equals to V. V is across the component. Okay, V is across the component 2.8 plus the voltage drop due to the internal resistance. Current I times your small r. Okay, so at here, sometimes they didn't provide you V across the component directly. It's okay. We can do calculation also by using the current in the circuit times your total resistance. So these three formula actually is the same thing. E equals to V plus IR or E equals to IR. So I times this R is your V plus IR, or you take out the I, factorize the I, so R plus small r. These three formula actually is the same thing, okay? So until here, is that clear before we practice the past year question? Any question? Okay, then we go. This is 2017, a battery of EMF 6.0 volt and internal resistance. If the past year question they didn't mention about internal resistance, we just assume perfect case. Okay, assume perfect case. Unless the question they say internal resistance, then we have to think back to this subtopic. Connected to the resistor of 12 ohm and a variable resistor X. By considering energy, explain why the potential difference across the battery terminal is less than the EMF. So this one actually is across. Here we got the voltmeter. Okay, so potential difference across the battery terminal. So for this one, actually is measuring what? Measuring our component voltage, potential difference across our component. Okay, so why this voltage is less than 6 volt? Why is less than the EMF, which is the 6.0 volt? Okay, maybe I can write in this way. Component is less than EMF, which is the 6.0 volt. Okay, why? Why? Okay, in terms of energy. So here 2 marks. One of the marks is because the energy is dissipated in the internal resistance. This is one of the mark. Why? Why cannot get 6.0 volt? Because some of the energy actually is dissipated in the internal resistance. Okay, one more mark at here. They want is you talking about what is EMF. Okay, EMF is the total energy. Okay, total energy available per unit charge. Okay, total energy, but why it cannot receive the whole energy from EMF is because some of the energy is dissipated in the internal resistance. Small r. Oh, no need lah. Okay, here, like this. If this question only 1 mark, then we write this answer. Okay, if this question only 1 mark, then this one is our answer. Here 2 mark, that's why one more point we have to give. EMF is total energy, but we didn't receive whole energy is because some of the energy actually is lost due to the internal resistance. There is internal resistance in the circuit. If only 1 mark, this is our answer. Second sentence, energy, because some of the energy is dissipated in the internal resistance. Potential difference across batteries terminal at here actually is the voltage across component. Because when we close the switch, we are measuring potential difference across component right now. The voltmeter actually is showing, no longer showing EMF. Okay, until here, is that clear? Washini okay, Fatima okay, Fawa okay. Okay, then we try with the second question. If you really understand the question, then you're able to answer this question. A voltmeter read 9.000 volt when it is connected across the terminal of battery. So they only connect to battery, only battery. There is no other component here, okay? So this one is exactly measuring the EMF lah, okay? When a resistor, okay, I write here first. This is EMF. EMF is 9.000 volt. Okay, when a resistor of resistance 11 ohm connected in parallel with the battery, so the circuit is like this. So this is the circuit, and then voltmeter is here. The voltmeter reading changed to 8.800 volt. Okay, now we close the switch. Now your voltmeter 8.800 volt. What is the internal resistance of the battery? What is your small r? Okay, for those graduate from SPM, you can try by yourself. The rest, graduate from IGCSE, now I step by step, I teach you. We're using the formula E equals to V plus IR. Okay, here, What is your E? E is your EMF. From just now, the first diagram, I know that my E is 9. What is my voltage across the component 11 ohm? I don't know. Okay, I don't know. Then what should we do? Can we calculate it up? Or no need to calculate because here, this one is actually the voltage across the component 11 ohm. No need to do calculation. What? So here is 8.8. When close the switch, actually your voltmeter reading is showing you the potential difference across components. So no need to do calculation. But here I want out. I don't know my I. Can you find your I? Voltage across 11 ohm equals to I 11 ohm, R 11 ohm. Okay, you can do calculation and find out what is your I. Farwell. Farwell, no. Wesley, yes. Wesley, yes. Okay, that means here 8.8 volt. So here 8.8 equals to the current, I don't know. Then your R is 11 ohm. So your I for 11 ohm, you will get 0.8 ampere. So that means current in the circuit is actually 0.8 ampere. Vashini, yes. Prasan, yes, correct. So deal. Okay, here. This is a series circuit. You see, series circuit. So the current flowing through the 11 ohm and the current flowing through the internal resistor R is the same. Okay, it's the same. Fawal correct. Fawal B correct. So at here 0.8, your R actually should be 0.25 ohm. Okay. This is the first time we try with internal resistance. So here, first, when open circuit, this one EMF. When closed circuit, so this is first very important information. Second, here. Okay, when close the switch, the voltmeter reading actually is the voltage across the component. So I know that 11 ohm will receive 8.8 volt. It will receive 8.8 volt. Okay, then from here, you need to calculate the current in the circuit. How you do calculation? Since you know the voltage for 11 ohm. Okay, then you know the resistance also, so you can calculate the current. Current flowing through the 11 ohm and the resistor is the same thing. Okay, it's the same thing. If I redraw the circuit, I can move my voltmeter to become like this. Actually, the circuit drawing is the same, something like this. Okay, I just move this part, the voltmeter, across this point. It's same as here. It's same as here. So can you see that right now, if I close the switch, the voltmeter at here actually is measuring 8.8 volt, is measuring the voltage across the 11 ohm. Okay, here this diagram I want to tell you, when close the switch, voltmeter reading actually is measuring the potential difference across the component. Doesn't include your internal resistance. Okay, until here, is that clear? Fatima, okay? Okay, everyone. So we go to your next page. Okay, can you try? Can you try? If you cannot, then you will look at my screen. I will give some hints. The rest of you try. Any of you get the answer? Those who don't know how to do, I tell you, the voltage at here, E, you already get 10. What is your V? V is the voltage across the component. Since these two paths is parallel, so you just either one to find the voltage. They will be the same. I cannot using the first path R, then 0.45 ampere, then 2 ohm. I cannot using that is because I don't know my R. So I using the second one to find my R, to find my voltage V. So you put it in. Then current flowing through internal resistance is total current. Is total current. Jore, yes, Jore, correct. How about others? Vashini, correct. Only two of you get the answer. Wesley, correct. Okay, here is my solution. If you have no idea, then I explain here. E equals to V plus IR. Okay, here the V is the voltage across the component. Okay, so outside the battery here, what is the total voltage? This is connected in the parallel way. So that means that they were having same voltage. Okay, first path and the second path, they were having same voltage. I cannot using the first path to do calculation for my voltage is because I have an unknown R. So it's okay. I using the second path. I got the current, I got the resistance. So I can know that voltage across the 15 ohm is 7.2 volt. So at the same time, I also understand this part, the first path, actually also having the voltage 7.2 volt. Okay, so voltage across the component, it will be 7.2 volt. Voltage across parallel, we doesn't add it up together. Okay, so this one 7.2, here 7.2, in overall it was 7.2. Okay, I times the small r internal resistor. The current is the total current because here current come in and then split. And then after that combine back, go back to the battery. So going back to the battery, this is total current. Total current is 0.45 plus 0.48. So at the end, I can calculate and get the internal resistance should be 3.0 volt ohm. 3.0 ohm. Okay, then at here, how I find the resistor R, okay, resistance R. So I know that just now the second path I received 7.2 volt. Right now my first part should be also 7.2 volt. My total resistance for this path is actually R plus 2. So my R should be 14 ohm. Okay, is that clear? Answer should be A. Any question? Is it okay for this part? 海谦 okay good job. Bawa okay, Vashini okay. Okay. Okay, dear here. You try. Try first. Internal resistor connected to the switch variable resistor, voltmeter is connected. When the switch is open, keyword switch is open. Switch is open, the voltmeter reading showing EMF. The switch is then closed. Then variable resistor is adjusted until 4.0 ohm. Voltmeter right now. Close the switch. If you close the switch, voltmeter right now actually is the voltage across the resistor, 0.75 volt. Okay, try. Wesley, good job. Yes, you already know the idea. Okay, how about others? Washini correct, Jore correct, Kaichen correct. Hey, good job, good job. So at here, I is equals to 0.188 ampere. So 0.188 ampere. Then after that, your answer should be 3.98 ohm. So it's actually 4.0 ohm. If we make it two significant figure, it will become 4.0 ohm. Fawal, no? Fawal, check. Which part you make mistake? Prasan, yes. Manjole, Manjo, able to get the answer? You use wrong value. So you try to, which value you make wrongly, you substitute wrongly, then you have to digest. Okay, so should be fine, right? This one is the reading for the resistor, voltage for the resistor. So resistor is 4 ohm, so you can calculate the current. Okay. Wesley, if use exact answer can get exactly 4. Oh, you means that my current here I already round off, is it, Wesley? Is it because I round off? So I get 3.98? Oh, okay. So if you're using the exact number, whole number, put it in. So at the end, we will get 4.0, exactly 4.0. Okay? This is the reason why in paper 2, we always want 2 to 3 significant figure. Because at the end, we still can round off to get back the same answer. Okay? So here, if no question, we go to your page number 8, question number 5. Okay. So what change happened when the 5 ohm load, this is load resistor, it's not the internal resistor. Okay, 5.0 load resistor is replaced by 50 ohm. Here, become 50 ohm. So 10 seconds, read the question and then you're trying to choose an answer. Now our load become 50 ohm. A, B, C, D, which one will change? Of course, is correct. Change correctly. Washini correct, yes. How about others? No idea? Jore correct. Kaichen correct. Fatima correct. Okay, deal. when our outside resistance, this one R, become higher, so overallly our total resistance also increases. Overall circuit total current will decrease. So A will be wrong. It should be decrease. Current should decrease. Okay, potential difference across the load resistor will increase. Yes, because resistance increase, the voltage that is shared will get more. So potential difference across the load resistor will increase. Yes, this one is correct. Okay, so the 10 ohm at here, 10 volt at here, it will get more for this part when here is 50 ohm. So the 50 ohm will receive maybe like 9 point something, okay, 9.1 volt. Okay, if you want to do some calculation, you really can get the answer out. Voltage across the 50 ohm, I did calculation, I get 9.1 volt lah. Then voltage across the 5 ohm on 5 ohm is only 5 volt, something like that. No, it should be only what it should be only okay. If 5 ohm, it will receive 5 volt because here 5 ohm is receive 5 volt. But when voltage becomes when resistance become 50 ohm, I get 9.1 volt. So it will receive from 5 volt become 9.1 volt. So the voltage increase. Yes, correct. Okay. Then power in the internal resistance will increase. Is it true? Your internal resistance, your R doesn't change, still 5 ohm, but because your current decrease, overall circuit current decrease, so P equals to I square R. So I square R can use small r. So when your I decrease, your power should be decreased. So this one wrong. Increase wrong. Total power dissipated in the circuit will increase. No, because current decrease, so power will be decreased also. So this one wrong. Answer is B. Okay, answer is B. So here, question number 6. Okay, think. Resistance of R decrease. Because this is variable resistor, so I can decrease the resistor. What happened to your current and what happened to the potential difference across the cell? Okay, potential difference across the cell now is a closed circuit. So basically, is potential difference across the component. Although it's connected the voltmeter at the cell there, but actually it's measuring the potential difference across the component. Okay, so at here, what is your answer? When your resistance of R, variable resistor, decrease. Washini, correct. Good job. How about others? Let me check. Wesley, correct. Fawal, correct. Good job. Okay, when your R decrease, total resistance decrease. Total current increase. So current should be increased. Actually, the idea is same like just now, but just now is increased from 5 ohm to 50. So continue IR, IT. Okay. So at here, the component, the voltage across the component. So it should be increase or decrease. So at here, when your IR increase, that means that E equals to V plus IR. So V equals to E minus IR. Because your current increase, so this part value will increase. Voltage potential difference across the internal resistance will increase. Then EMF is constant. So what's going on with your voltage across the cell, the potential difference across the cell, or we say across the component? So this part, E minus a big value, so your voltage should be decreased. Answer should be C. Okay, let me check. Hai Qian, correct. Okay, any question? Did I explain clearly for this part? Do you able to get the idea? Okay, good job. Okay, here, next question. Internal resistor, the battery is replaced by a different battery with same EMF. EMF doesn't change, but now greater R, small r. Just now it's asking you the big R, external resistor. So now it's small r. What happened to your ammeter and what happened to your voltmeter reading? Wesley, no. Wesley, no. Washini, yes. Greater internal resistance, R increase. What happened to your total resistance? What happened to your total current? Wesley, yes, right now. You get the answer, correct? Fatima, no, the second part is wrong. Voltmeter reading. Okay, dear, when your R is increased, total resistance is your R plus small r1. Okay, so your total resistance should be also increased. In total current will decrease. So A or B only. Okay, only A or B. So how about the voltmeter reading? Fawal, no. Answer should be voltmeter reading. Okay, voltmeter at here, dear. Voltmeter connected is outside resistance, it's not internal resistor. Okay, so at here outside, so V is E equals to V plus IR. So your V is E minus your I times R, right? Okay, so at here, because your internal resistance, this one is increased. So that means this value also increase. So what happened to your V? E minus a big value. So your V should be decreased. Answer is A. EMF is the same, doesn't change, constant. But they increase your internal resistance. So for the second part at here, this value become bigger. Potential difference across for the internal resistor is higher. So your voltage across the outside component is actually decreases because internal resistor receive more voltage. Is it okay? Is that clear? Fatima, okay. Fawa, okay, So if okay, then we go to the question number 8. Initially, switch S is open. After that, what happened when the switch S is closed? What happened to your voltmeter and ammeter reading? Think. After we close the switch, what's going on? So how your ammeter and voltmeter reading will change? Fatima, Fatima, you rethink about the ammeter. You rethink about ammeter. What's going on with the ammeter? Jore, yes. Jore, correct. Wesley, you rethink about the ammeter. Rethink about the ammeter. When you close the switch. Kai Qian, correct. Washini, correct. Okay, here, when we close the switch, what happened to your total resistance right now? This part. When we close the switch, this part become parallel. So at the end, this part, the resistance value actually is decreases. Agree? So at here, when we close the switch, it becomes parallel circuit right now. So it will reduce the resistance. Manjo, correct. Okay, so at the end, your total resistance will decrease. So what happened to your total current? Total current should be increased. So here, increase. Okay, then after that, what happened to your voltmeter? Voltmeter is actually is E minus IR. Okay, we rearrange the formula only. So your E is doesn't change. This one is constant, doesn't change. So your current at here, overall current is higher. So at here, this value is actually a big value increase. So this part, it should be decreased. Answer is A. Okay, is that clear? Fatima, okay, then we can proceed to your page number 10. Okay, we goes to your page number 10. This one no need lah. This one easy. So volt per ampere. Okay, now we try with paper 2. A battery of EMF E and internal resistance 1.5 ohm is connected. Okay, resistor X has 8 ohm. Then resistor Y 2.0 ohm. Then resistor Z is unknown. Okay, the current in the X is 0.6 ampere. Current in Y is 1.8 ampere. Actually, all is level inside the diagram already. Okay, can you calculate the current in the battery? In the battery, that means that total current. Easy, right? This one, total current. So here they show you they split. So how we know the total current come out from battery? Add it up together, that's all. So here, 1.8 plus 0.6. So our answer is 2.4 ampere. Current in the battery. It's total current. Just add it up. Fatima, correct. Okay, here, what is your resistance RZ? Can you try do calculation? What is this resistor? Think how you find this resistor. You cannot using the formula E equals to V plus IR is because E is unknown. And then some more third question asking you to find E. That means that we are not yet using the formula E equals to V plus IR. This one is finding at here. Okay, so you have to think how we find what is this resistor Z. Any of you? Wesley, let me check. Yes, good job, Wesley. Wesley already get the answer for 1, 2, 3. No, Fatima, no. Fatima, I give you some hints. These two paths is parallel. So parallel, that means that they will having same voltage. So what is this voltage? It will be the same as this part. Then using the voltage to find what is your R. Let me check Manjo. Manjo, no. Manjo, no. Washini, yes. Washini, yes. Fawal, no fraction in physics. No fraction. Do it in decimal. Those who don't know how to solve, again, here, these two path is parallel path. That means that this voltage X actually is voltage Y and Z. We can find the voltage X is because I know the current and I know the resistance. Then the voltage will be equals to this part. Okay, then you can calculate what is your RZ. Fatima, yes, but Fatima, you cannot give me one significant figure, cannot. Kai Qian, no. Kai Qian, no. Manjo, right now, yes. Jore, yes. Okay, so dear, I repeat, here, if I connect a voltmeter, so my voltmeter here, voltage for X actually is voltage for Y and Z. Because they are parallel. So here 0.6 times 8 will be equals to 1.8 times 2 plus 1.8 times your RZ. So from here you can calculate your RZ. Get it? Just now we did this kind of question. Kai Chen correct right now? Wow, yes. Okay, so here the answer should be 0.67 ohm. Don't give me 0.7 ohm. Two significant figure. Okay, two significant figure. Okay, so this answer is question number 2. Question number 3 asking you what is your E. Number 3, what is your E? E equals to V plus IR. So, what is your E? Your V, external, okay, the resistor voltage across the X is how many? 0.6 times 8 plus total current. Okay, the current flowing through the internal resistance actually is total current. Current flowing through the internal resistor is total current. So it should be 1.8 plus 0.6. Your R is 1.5. Internal resistor 1.5. Okay, let me check. Manjo. Correct. If you do it correctly, 8.4 volt. Is that clear? 8.4 volt. Here I want to emphasize current flowing through the internal resistor is total current. It's total current. Voltage across the component, actually I just need to count either one. Here 0.6, 4.8. Okay, 4.8. For here is 4.8. Then for this path also 4.8. So overall, the external circuit here, the voltage should be 4.8. You don't need to add it up. Voltage cannot in parallel, cannot add it up. Okay, is that clear for this part? Yes or no? Hai Chen okay? Fatima okay? This question, similar question just now, we did this question before that. Okay? Okay, we go to your question number 10. A wire X has a constant resistance per unit length. So this one is resistance. Resistance per unit length is 3.0 ohm meter negative 1. Okay, diameter. So be careful with the prefix. This is a prefix. The battery has an EMF 5.0 volt. E equals to 5.0 volt. And internal resistance R is equals to 2.0 ohm. The wire X and a resistor R of 4.5 ohm are connected in parallel. The current in the battery is 1.6. Current in battery is total current. Can you calculate the potential difference across resistor R? Can you do calculation for your potential difference across resistor R? Do it right now. Fatima, no. Fatima, you using this formula. So you already get the E. Then this one is the value that we want to find. Then here, this one is small r. This is the total current. It's already provided in the diagram. So this is the internal resistance is 2 ohm. Then you're able to find this. Vashini, yes. So Fatima, you try this. Correct, Fatima, correct. Vashini and Fatima can proceed to the next question. How about others? Do you able to get the answer? Our answer should be 1.8 volt. 1.8 volt. E equals to V plus I R. The I is the total current. It's already provided in the diagram, which is 1.6 ampere. EMF is 5, so you can calculate the V. Okay, so next, determine for the wire X. What is the resistance? What is the resistance? What is this R? Manjo, yes. Manjo, correct. Good job. Fawal, yes. Correct. Fatima, no. Vashini, yes. Okay, I know that here to here is actually 1.8 volt. I want to find R. So my question is, how can I know the current? Actually, many way to solve. Many way to solve. Fawal, correct. C, number 2, correct. Wesley, correct. Yes. Okay, dear, here, for those cannot solve, so you look at me. Just now, the 1.8 volt, we already count for this part, 1.8 volt. So that means that wire X also 1.8. Okay, wire X also 1.8. Then I want to find the Rx. So what should I do? I should know about my Ix, am I right? Just now is 1.6 is total, but I don't know how much is going to our wire X. Okay, can I know from here first? Okay, so the V equals to IR. So this one is 1.8 volt. Current, then the resistance 4.5. So I know that the current, it should be 0.40 ampere. So this one is 0.40 ampere. So that means that they got 1.2. Okay, here got 1.2 flowing. Get it? Fatima, here, this part I explained. Did you able to get it? Jore, correct. Kai Chen, correct. Okay, so Fatima here, I know this is 1.8 because just now the first question I did calculate 1.8. Then after that, I want to know this resistance. I know the voltage, but I don't know the current. So second step, I need to find the current. Current for the R at here, I know that is 0.4 ampere. So that means that here, the wire X, it should have the current 1.2 ampere. So from here, Vx equals to Ix Rx. So voltage is 1.8, current is 1.2, Rx unknown. Rx is actually will be 1.5 ohm. So this one is the number 2, answer for number 2. This is step 1, step 2. Okay, try. Fatima, yes. Correct. Okay, the last one. What is the length? Wire X, what is the length for wire X? Okay, how we know? Just now the first sentence they tell you wire X have a constant resistance per unit length. Okay, every 1 meter is 3 ohm. So now it's 1.5 ohm. So what is your length? So at here, third one, 1, 2. Okay, so R over L is 3.0 ohm per meter. That means that 1 meter is 3 ohm lah. Right now it's 1.5. Yes, Vashini, correct. So here resistance is 1.5, the length unknown, so 3. So length will be 0.5 meter. Okay, you see, this one means that every 1 meter 3 ohm. Every 1 meter 3 ohm. Now we got 1.5 ohm. It's half of the 3 ohm. So that means your length is half of 1. No? So it's 0.5 meter. Okay, until here, is that clear? For the second one, actually, there is so many ways to find out the resistance X. So many. You can find your working step might be different as me. As long as you're able to find resistance wire X is actually is 1.5. That's all. There is so many methods. At least 3 methods. Okay, until here, is that clear for this question? Okay, we are going to proceed to the next page. Okay, related with the graph. If they plot the graph, okay, they do the experiment, they plot the graph. This is the graph that we get. Teacher, normally we learn about the V and I graph. Is a directly proportional. Is Ohm's law say that it will be directly proportional? Yes, that is the theory that we didn't consider internal resistor. But right now we consider internal resistor. At the end we plot the graph, we will find out that it will be this graph, okay? They will get a negative gradient graph. So at here, from this graph, actually there is 2 information is very important, okay? Which 2 here? Number 1, your y-intercept can tell us that that is the value of EMF. This is a very important information. Y-intercept is EMF. Why? Because here, when current is 0, here is current, I, x-axis is current. When I is 0, this value, I0 means what? Open circuit, okay? Open the switch, okay? Open circuit, the circuit is doesn't connected. Okay, here, the I is equals to 0. The voltage at here actually is the voltage of EMF, is the value of EMF. So this part actually touching to your y-axis, this is EMF value. One of the past year question they're asking you how you know that the EMF value is equals to this. How we know from the graph? It's because when current is 0, that value actually is represent EMF. Okay, the second one is what else? The second information that can provided to us is the gradient. The gradient that we calculate actually can let us know about internal resistance. Internal resistance. So at here, if we find the gradient, we will find out that we're using the V minus the EMF divided by the current, x-axis. Y-axis divided by x-axis. At the end, we found out that the gradient is represent the internal resistance. Okay, if I using the EMF, EMF equals to V plus IR. We can using symbol E, okay, E. plus I out. So at here, E minus V divided by I actually is R. Am I right? Okay. So if I put a negative for both sides, negative, here also negative, okay, then at the end it will become E minus V over I minus R. So here will be V minus E over I actually is, what the gradient that we get actually is internal resistance. You don't need to know about this actually. You don't need to know about this. But for those who are very good, you're asking why from here I know this is internal resistance. Actually, you rearrange the formula and going down, you will find out that V minus the EMF divided by I actually is negative R. It's the negative internal resistance. Okay, negative is because this gradient is going down. Okay, negative gradient, so it's negative. So we want to know the value of resistance, we just take the magnitude, that's all. Okay, so from this graph at here we found out that, or you don't need to consider about how I derive. From the graph we also can know, we know that mathematics y equals to mx plus c. Then here, your y-axis is your V voltage. Your x-axis is your current I. Okay? Then this is a negative gradient, so it's negative R at here. We rearrange. At the end, we found out that our y-axis is actually, not y-axis, y-intercept actually is EMF. Okay? Gradient is represented by the internal resistance represented by the gradient. That's all. Only two things you have to know from the graph. Y-intercept, EMF. Gradient, internal resistance. Okay, until here, is that clear? Okay, then we practice, we go to the next question. Past year question here, we practice. Okay, here, this one is EMF 3.0 volt. Internal resistance 0.5. Then we got voltmeter, ammeter. Variable resistor is changes, can be changed. So reading on the ammeter and voltmeter reading I record. Which one is the correct graph? Okay, so based on the first point, EMF, we already can cancel out two answer. Then after that, continue. Try A, B, C, D. Which one is the correct answer? Wesley, correct. Jore, correct. Fawa, correct. EMF is 3.0 volt. So A and D can cancel out. Left C or B only. Washini correct. Fatima correct. Kaichen correct. Answer is C. Okay, here is when V is 0. So E equals to V plus IR. Okay, when V is 0, this one cancel out, becomes 0. Your E is 3. So your current we don't know. Your internal resistance is 0.5. So your current should be 6.0 ampere. Okay, so answer should be C. When at this point, voltage is 0. When no voltage, what is your maximum current in the circuit? Okay, internal resistance 0.5, do some substitution, you will get current is 6.0 ampere. Okay, until here, is that clear? Okay, we go to your next page, page 14. Page 14, this one a bit tricky, okay? We do it step by step lah. Okay, this one is the cell of EMF E, internal resistor R. Then this variable resistor can be changed, gradually increase from R to 3R. So we got two cases. We got case 1. Okay, your R is R. Case 2, your R is 3R. So from here, change to 3R. R change to 3R. Okay, then after that, which graph show the variations of potential difference V across internal resistance? So y-axis is the V across internal resistance. V, small v, I times small r. Then x-axis is across the variable resistor big V. So I times resistor R. Okay, so A, B, C, D. Wow, how I know? Okay, then we have to do some substitution step by step to solve it. E equals to V plus I times R, right? Okay, then also can say that E equals to IR plus IR, right? Okay, right now, my R is small r. Okay, E equals to 2IR. Agree? Okay, now I want to know my x-axis V, big V. Okay, x-axis, big V, V equals to I times R. My R right now is small r, which is 1R. Okay, but my I, what is my I? So at here, I is equals to E divided by 2R. So I do substitution, E divided by 2R. Then what we get? Cancel, cancel. So 0.5 E. My starting x-axis should be 0.5 E. Okay, my x-axis, my y-axis, okay, my y-axis is small r, I times r. So your I is E over 2R times small r, again, also 0.5 R, 0.5 E. Okay, the idea is like this. So can you using the same idea to solve when the case of R becomes 3R? Use the same method, continue, then I know that second point. First point, x-axis at 0.5. Y-axis at 0.5 also. So that means that we are starting from 0.5 and 0.5 here. But where is our second point? Here V equals to I times R. My R becomes small r, 1R. Then I cannot using I is because in terms my graph here, they are in terms of E. So I need to make I disappear. Then I need to, in terms of E, okay? Make the I in terms of E. You using the same method, solve the R when the R is 3R. Try it right now. Any of you get the answer? Same method, E plus IR plus IR. Now the big R is 3R. So my E is actually become 4IR right now. Okay, because in the graph, there is no involved with current I. So we need to replace the I in terms of E. So EI will equals to E over 4R. Okay, then we think about the x-axis. X-axis is the resistance across the variable resistor, big R. So you just substitute the current and the resistance. Jore, correct. Jore, correct. So Jore roughly can get the idea for this question. This one is tricky. This question is tricky. Wesley, yes. Wesley, yes. Cannot understand the question at first, but right now, is it okay a bit? Because here is small v, internal resistance. This one is big V. This one is across the resistor. So you need to find out the point. Okay, now. Yeah, need time to think. Okay, so boys and girls, here, when the first case R is small r, the point is 0.5 E and 0.5 E. This is our first point, okay? When from small your resistor right now is 3R. Your current, I cannot use the current 3R current because in this graph, it doesn't having any current. They are in terms of E. Okay, so we need to do substitution and make the I disappear, then make the E appear in the formula. So E over 4R times the resistance right now is 3 ohm. Okay, here is 3 ohm. So right now here also 3 ohm. Okay, then after that we get 0.75 E. For your y-axis actually is internal resistance small r. So I times small r at the end is 0.25 R. So at here this is 0.25, no E. This one 0.25 E. Okay, so answer should be A. Second point at here actually is 0.75 E and then 0.25 E. This point is actually 0.5 E, 0.5 E. This question have to digest. If cannot, then you print screen and then you rethink again. Step by step, think about my working step. Answer should be A.